Hello, Integrated Math 1. Welcome to lesson 2.4.3a. We're getting crazy now. So we've been using distance formula like a mad thing. And it's going to come back because we can't avoid it. We've been finding areas and perimeters of rectangles and triangles. But we know there are a great many shapes in this world that are not rectangles and triangles. That's just life. So we're going to take this to the next level. We're going to kick it up a notch. You ready? I actually really like this lesson. So we're going to determine the perimeter and area, parallelograms on a coordinate plane, and more importantly, composite figures on a coordinate plane. So we're going to talk about what a composite figure is. That is a key term today. And you've determined the perimeter and area of rectangles and triangles. You know how to do that, right? I mean, again, if you need a little reminder, this is what the pen is for. For rectangles, we know the perimeter is double the length plus double the width. We know the area is base times height. For triangles, we know the perimeter is just add up all the sides, right? I want a lowercase a, sorry. I'm fussy, it's fine. So A plus B plus C, and of course the area is 1/2 of the base times height. We are experts now with rectangles and triangles, okay? How can we use those shapes, those rectangles and triangles, to determine the areas of other polygons on the coordinate plane? So the method you use to determine the perimeter of a rectangle or triangle can actually be used with any polygon, right? Perimeter is just the distance around it. If you can find all of the distances, all the lengths of all the sides, you can just add them up to find that perimeter. And you can use the distance formula to calculate the distance between any set of vertices. And then you would just add up all the lengths of the sides. That's all you have to do. So you can determine the area of any composite figure by dividing that figure into a combination of rectangles and triangles. So perimeter is one thing. Use distance formula, figure out what all the sides are, add them all up. Great. If you want the area, then chop your figure up into rectangles and triangles. You know how to find the area of rectangles and triangles, so chop them into rectangles and triangles. By the way, when we're referring to a composite figure is a figure that's formed by combining different shapes. So if you're on page 290, M2-290, I have for you one heck of a composite figure. This is a composite figure. There's all kinds of weird little shapes together that created this one. This is Carter's backyard. Sometimes you just get a weird lot and it's kind of on the hills and there's rocks and it's weird. So Carter has a very irregular backyard because it backs onto the foothill of a mountain and it's very rocky. So this composite figure graphed on the coordinate plane represents the usable area of Carter's backyard that's flat. So this is what's flat. This is what you can use because there aren't big boulders in it, all that good stuff. Please notice, each interval of the coordinate plane represents 2 yards. Are you catching that? That we're counting by 2s on the grid line, not 1. That's gonna help. And yes, it does represent yards. Oh, we got units involved now, baby. We got units involved. Oh, yes, we do. So Carter is going to install fencing all around the flat area of his backyard. Let his dog run around, right? I would like you to determine the amount of fencing he needs to the nearest whole yard. So if he's trying to find fencing to put all around the outside of that yard, as weird as it is, you might want to ask yourself, are we finding perimeter or area? And once you've decided, go for it. Go ahead and hit pause to work this out. Hit play when you're ready to check your work. So if he wants to know fencing and he's going to put it around the outside of the yard, this is perimeter, right? I mean, we're finding the perimeter. This is totally a perimeter problem. So I'm just going to make a little note here. We're doing perimeter, right? So if we're doing perimeter, we got to figure out all of these lengths. Now, some of these are easy, right? The ones that are horizontal or the ones that are vertical, you can just count. So if I count this guy, remember each grid is 2. Please be careful. So 2, 4, 6, one more makes that 7. So that has a length of 7. 2, 4, 6, 8, 10, 12, 14, 16, 18. Woo! That's probably where the house is, right? That's the side that the house is on. 18. Oh, that one's slanted, which means I'm going to need some distance formula. I'm going to come back to GH. I'm going to come back to GH in a little bit because that's slanty. Anything that's slanted, we know we're going to need to use distance formula. I'm going to do the flat guys first. FG, so 1, 2, 3, 4, 5, 6. All right. 2, 4, 6 for EF. 1, 2, 3, 4 for DE, and 2, 4, 6 for CD. Oh, another slanted one. I'm going to have to use distance formula for that one too. So we'll come back to CB. In the meantime, AB 2, 4, 6, 8. That has a length of 8. So I know most of the links, but I need to do a little bit of distance formula to help me do CB, to help me do GH. Let's start with CB. It looks like CB, I do want the coordinates there. It looks like it's 2, 4, 6, 7, -7, and then up 4. And it looks like B is sitting at 3, -2. So B is at 3, -2. So I'll subtract my x coordinates, -7 minus 3, subtract my y's, 4 minus a -2. This, of course, becomes 4, -7 minus 3 is -10. This becomes 4 plus 2, which is 6. Square those, I get 136, which is 136. And the square root of that is about 11.66. So we just found out that this length is about 11.66, which isn't all that great, but it'll work. Let's find the length of GH. Right, let's find the length of GH. So again, I need some coordinates here. G is at, looks like we had to go right 3 and down 8. So 3, -8. It looks like H, we had to go right 10 and down 12. So that's a -12. Awesome. I'm going to subtract my x coordinates, 3 minus 10. Subtract my y's, -8 minus a -12. I keep ending up in darkness. Sorry, guys. I gotta like fling my arms around so that they know I'm here. 3 minus 10 is -7. This becomes -8 plus 12, which is 4. If we square those, we get 49 and 16. Together, that's 65, and the square root of that is about 8.06. So I have all the sides. Let's add them up. So 7 plus 18 plus 8.06 plus 6 plus 6 plus 4 plus 6 plus 11.66 plus 8. Grab a calculator. I'm not doing that in my head. So I grabbed a calculator and I got about 74.72. So that's how much fencing. We need units. We need units. And we need to explain. So determine the amount of fencing he needs to the nearest whole yard. I need to round to the nearest whole number, don't I? Oh my gosh. So it looks like Carter's going to need at least 75 yards of fencing. Usually when you go to buy fencing, you have to buy by the yard, by the foot, that sort of thing. So it looks like he's going to need 75 yards of fencing. Okay. Now he's got his fence up. Yay! And now, inside of the fence, Carter wants to lay sod in the flat area of his backyard. And now I want you to determine the total area of sod he needs. There may be a clue there. My advice to you, before you just dive in and go, is you might want to cut up his yard into triangles and rectangles because you know how to find the area of triangles and rectangles. So cut it up into bits that you know first, find the area of each piece, and then add them all back together again to get that total area that he needs. Hit pause to work this out. Hit play when you're ready to check your work. So when I did this problem, I realized that if I cut this off here, I would have a big triangle. So I cut that off. Pardon me, it gives me a nice big triangle. And then I was like, oh, I kind of have a little squarey rectangle-y thing kind of going here. So I cut that off as well. And I realized if I cut off this end piece, I would have a rectangle and a triangle. So that's what I did. You may have cut it into slightly different pieces, but that's okay. It can still work. Just make sure that you're careful and you add everything back together again. So I'm going to start with this lovely triangle here. We already said from earlier that the height of that triangle was 6. And if I look at this carefully, I can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like the base of that triangle is 10. So if I want to find this area, it'll be 1/2 base times height. So 1/2, 6 times 10, which turns out to be about 30. This actually is a square. If you recall earlier, we found out earlier when we were doing perimeter that that side was 6 and that side was 6. So awesome. The area of this lovely little square is going to be 6 times 6, which is 36. Great. Let's do the big rectangle. Let's do the big rectangle. We already know what this side is. It's 7, right? We found it earlier. This has changed though because I don't want to go all the way down 18, the whole length of 18. I only want to go from here to here. So 1, 2, 3, 4, 5, 6. I got to count by twos. 2, 4, 6, 8, 10, 12, 14. So it looks like that side is 14. So I will just do 7 times 14, which is 98. Thank goodness for calculators. And last but not least, I do have, and I called this point I, just so you know. I was like, that's I. This lovely triangle here, well, that's 2 4s, so it looks like I've got a height of 4, and my base 1, 2, 3, 4, 5, okay, 1, 2, 3, 4, 5, 6, 7. Oh, same as the other side. It was a rectangle. So it looks like my base is 7 and my height, just flipped upside down, is 4. So since it's a triangle, 1/2 7 times 4, which turns out gives me 14. And I'm just going to add these all back together again. 30 plus 36 plus 98 plus 14. And it turns out the total area is 178. Let's make sure we answer the questions. Determine the total area of sod he needs. Well, we said this was in square yards. So it looks like Carter needs at least 178 square yards of sod. You might want to get a little extra just to make sure. I'm just saying. As always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, just let me know. Come talk to me, and I'll see you guys soon. Bye.